Sometimes people are afraid of coding math equations in programs. They see something like what you see up here and they don't know what to do. Moreover, they might see something like this and they might go, wow, this is something I can never code. And what I argue is that this is just a problem of translating from this language to the language of programming. And you might know both, you just might not be aware of the translation. So what I'm going to do first is code this one. And this one is a very simple function, is the factorial of a number n, right? So this will translate into a function. I'm coding in Python, you can code in anything. By the way, my Python programs for these functions are not going to be the optimal or the most Pythoniac. I just want to illustrate how to code these functions, and they can afford many, many optimizations. Okay, so for example, first you have to define a function in whatever language you like. I'm going to use Python. Well, we're going to call it factorial, and it's going to have one parameter, n. So factorial of n. Okay. So it says that it's the same as n exclamation mark. This is just a notation. This notation here is the same as saying factorial open parentheses n close parentheses. And here's the key thing. This is a product symbol. And basically it's a for loop in which you will be multiplying whatever is to the right of the product symbol. Okay? And the for loop is going to go from 1 to n. And the variable that we're going to use for the for loop is the variable I. Okay? And at every given iteration, we're going to multiply I times whatever was there before. So let's do this. We're going to define a temp variable that's going to allow us to accumulate the multiplications, because that's what the product means. And of course, it's going to start at 1, because if I started at 0, then I'm always going to be multiplying by 0. So temp 1. Then what I'm going to do is what I said. This is a product symbol, and it's really a for loop in which I will be multiplying stuff. So it's going to be a for loop. What is the variable of my for loop? It's called I. And I is going to be in the range, or from and to, whatever you want to do in your language. Range from, starts at 1 and ends at the value n. Remember, the value n was passed as a parameter over here, right? This is the value n in the formula. So to n. Now here's the thing, just because of Python, if I say range 1 to n, that's going to go 1, 2, 3, 4, 5, all the way up to n minus 1. So I have to add 1. This will effectively go from the number 1 to the number n in Python. This is a language quirk. All right. So in this for loop, what I will be doing in this for loop is I'm going to update temp. Temp is going to be the same as whatever was there before times I. You see the variable that I'm multiplying every time is I. Remember, this symbol means I goes to 1, 1 times. Then the next iteration I is 2, so it'll be 1 times 2. The next iteration it's 3, so it'll be 1 times 2 times 3, right? So this is what this product symbol does, and this is what I'm doing in my program. I call the function, I get the parameter n, I design a temporary variable to hold this multiplication, and this is the iteration part of the product symbol. This here is the iteration part of the product symbol, and here's when I'm actually performing the multiplication, right? And then finally, I just return temp. And we can test this function, right? So if we say factorial of 5, that should be 1 times 2 times 3 times 4 times 5. And let's do it. 1 times 2 times 3 times 4 times 5 is indeed 120. So this function is working. We're doing this formula. We translated a product with an index with a starting number and an ending number, and then something in here. We were able to do it. If this symbol in here gets complicated, right? Well, what gets complicated in the program is this middle section, because this corresponds to whatever happens in this symbol here. Okay? So I'm going to illustrate a little bit more complicated stuff and a different symbol here, okay? Next. So for example here, we have the symbol E, which is 2.17 something something many decimals, right? And the symbol E can be computed by summing this sigma here stands for summation, okay? By summing 1 over n factorial, and the iterations at each n will be 0, 1, 2, 3, all the way to infinity. So if you sum, we have the factorial right now, right? So we can do the following. We can do 1 over, whoops, 1 over the factorial of 0, oops, 1 over the factorial of 0 plus 1 over the factorial of 1, right, plus 1 over the factorial of 2, and so on and so forth. This is what this symbol is, right? All the way to the factorial of infinity, okay? So this is going to go from 0 to infinity, and it's going to be adding 1 over the factorial of whatever this n happens to be at the given iteration. So if I were to continue in Python, I would do 1 over the factorial of 3, and so on and so forth. Let's see where we are up to here. We're at 2.66. If you do this actually for 10 or 12, you get a pretty good approximation of the number E. So you don't really need to go to infinity, okay? So let's do this formula. Let's do a little bit of this formula here. Well, so first the function E, I can define E with no parameters, okay? People usually also call it exp, okay, but let's do E with no parameters. And what this is going to be, again, I'm going to have a temporary number that will store this summation, right? That will store the first term plus the second term and the third term and so on at each iteration, okay? And it starts at 0 because sums, you know, they will be adding. It's not like multiplying 0 times something that's always 0. You start from 0 and then you keep adding to it. Then the actual sigma symbol, this is again a for loop. The only difference is that inside the for loop, we're not going to be multiplying, we're going to be adding stuff. So let's start with the for loop. This is going to be a for loop for n, and it's going to go in the range of 0 all the way to infinity. I don't want infinity, I'm going to say, you know, 100. That's effectively going to go from 0 to 99. Okay, but that's fine. It's plenty to compute the value of E. How do you decide how high to go when it says infinity? You got to use other packages to see what's a good approximation. I've done this before, and I think that actually 12 is a pretty good approximation with like up to 9 decimals or so. So inside this summation, I'm already doing 0 to infinity or 0 to 99. I'm going to do 1 over the factorial of n, right? So I'm going to say temp is going to be whatever value is there plus 1.0 over the factorial of n. Where's n coming from? Well, n is in here, right? Where's this n coming from? N is the index, right? So it's going to be 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, and then you keep adding those things together, okay? And we already have the factorial function, so I will just use the previous function. And this goes to a very important point. When these mathematical symbols get complicated, it's better to separate things into smaller functions and then just call them from your main summation or your main equation. Okay, and once I have this, I will return, once the for loop is done, once the summation is done, I will just return temp. And let's do this. So if I call E, I'm going to get 2.71 something. Yeah, this is accurate to almost every decimal here. Okay? And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 decimal points. Okay? Again, we computed this formula, we translated it into code, like so. Okay, the summation was nothing but a for loop. Okay, that went from the lower range of from the index letter, from the lower range to some high range in this case because it was infinity, right? And I just use a temporary variable to accumulate my results. Again, as I said before, if you're a Python fan or something, you know that this can be done very differently and more Pythonic or whatever, but that's not the point of this video. The point of this video is to translate the formulas into what makes sense in programming generally. All right, now what if you have this other type of formula? In this formula, we want to note two things. First, x is a collection of numbers, or I'm going to think it's a collection of numbers, so x1, x2, x3, that can be any number in the first position, any number in the second position, and any number in the nth position, and any number in between. And I'm going to define AVG of x as the average. Okay, that's going to be 1 over bar x bar. Bar x bar means the length of x. Okay, so in this case, it'll be n, whatever n is. If you have a set of 5 numbers, then the length of x is 5. It's the length of x times the summation of each element of x, okay, of each xi. So I is going to go from 1 to all the way to n, okay? And remember, n this time is not passed as a parameter, it's the length of the collection, okay? How do we know that? Well, because in the collection it is defined all the way up to n here. It says the last element is x sub n. So I'm going to have a little index I that's going to go from 1, 2, 3 all the way to n, and I'm going to be summing the x sub that index. Now in computers, right, this will be an array or a list. Okay, an array, list, or any structure that stores a collection. Okay, and this x sub I is going to be whatever element at index I of that collection. So let's do the most obvious way for this. So we're going to define, I'm going to skip a few lines. So we're going to define the average of x being a collection of numbers, like so. Again, because it's a summation, we're going to have a temp variable that's initialized to 0. We're going to have a for loop for I in range. And then here, what's the range? It's going to start from 0 in this case, okay, because here the indices start on 1. But usually in many programming languages, the index of an array starts at 0, right, and ends at n minus 1. So we're going to go from 0 to all the way to the length of the array minus 1, the length of x. Okay, the range operation here does the minus 1 for me. So the length x minus 1 is already taken care of. But again, this is a programming language characteristic, right? But basically you want to loop from a variable I, which is going to be the index, in a range of 0 to all the way to the last number, right? To the last index. This is what I is doing here. I from 1 in this case to n, well, from 0 to n minus 1 is also works for arrays, okay, or lists in Python. Okay, and inside I'm going to just update my temporary variable. It's going to be the temp plus the element of x at that index, x at index I, okay? And then look that in this for loop I've taken care of the summation. We did this before. We did a summation before. So that's a summation. Now I have to multiply by 1 over the length of the array. So what I will do is I will update temp one more time, and it's going to be temp times 1 over the length of the array. And then I will return temp. Okay? So I effectively did the summation first. I actually switched the order here. I did the summation first, and then I multiplied by this. Okay, and that's the average. And we can test this. Say, for example, we have grades. Grades, and grades is an array or a list of your grades, and you have a 3.4, a 4.0, and a 3.8. Okay, and then the average of these numbers is 3.73, which is correct. Okay, it's the average of these three numbers. Okay, so this function average works like this. Now you might see this same function, okay, written like this. It's slightly different. Look at the differences here. You have an index that loops through an element here, and in here you don't have an index. What this means in math is that you have an x that goes from x that has elements x1 all the way to xn, meaning the length is n. And the summation here, which is the only part that's different, goes from x in big X. Little x means for every element in big X. So little x is going to take the value of x1 first, then the second element, the third element, and so on and so forth up until the last element. Okay, and this is another way of writing these same things. And we can define an average function that's just like that. Again, the average of x, right? I'm going to have a temp because that's initialized to 0 because I have a summation. Then I'm going to have a for loop. But this for loop doesn't loop through an index. It loops through the elements of the array. So little x in big X. Little x in big X. Look at the mouse. Little x in big X. That's what I'm doing right here. So for every element x that is inside the big collection x, what I'm going to do is I'm going to update the temp variable as temp plus that little x. And then at the end, I'm going to update temp just like I did before, temp times 1.0 over the length of x. And then I'm going to return temp. And we can do, again, we still have the grades there. And we can do average of grades using this new average function that we just created. And it's the same 3.73. Okay? So this is how you would interpret this formula into a function. Okay? And lastly, I want to do a quite complicated formula, okay, to understand that this is not, you shouldn't be scared of this. Each summation symbol is a for loop. So this is a for loop here nested inside another for loop. That's all it is. That's the trick, the only trick here. And this is the variance of a collection of numbers. So x is the same collection of numbers that has elements 1 to n, right? It's of length n. And the variance tells you how spread these results are from the mean. It's a statistical term, but for now, we don't care what it means. What we care is, can we code this formula in Python or in whatever language? So I'm going to do this. So we define the variance of a set X, right, of a collection X. Again, there's summation, so I'm going to need a temp variable. Temp's going to be 0. And then what I'm going to do is I'm going to need a for loop that goes from I in X. Now I is not an index here. I is an element of the collection X, and J is an element of the collection X. So I'm going to do for I in X, right? That's the first summation, and then, which is the first for loop, and then the second for loop for J in X. That's the second for loop. Okay, I'm going to update temp. Temp is going to be, and here we go, whatever was there before plus 1/2, right? 1/2, I'm going to put it in parentheses just to clarify, just to be very clear about this. 1/2 times, and I look at the formula here, I minus j and that square. So I minus j and that square. This is how you square things in Python. Okay? I minus j square. And that's good. That's the only update I need. You see temp at every iteration of j and I'm going to be updating the variable that's inside here. Once I do that, I'm going to update my temporary variable to be, I just did the 2 for loops for here. I'm just going to multiply this term now. And this term is 1 over the length of x squared. So this is going to be temp times 1 over the length of x squared. That's how you square things in Python. And then I'm going to return temp. And that's my function. And I can compute the, again, I have my grades, and I can compute the variance of those grades. And I'll get, this is the variance of those grades. But the most important thing is we've just coded here, we just coded a function that actually runs through this math formula pretty literally, okay? Again, Python offers a lot more to compute this kind of formulas in a lot more succinct way, but it doesn't matter. You can translate this to Java or whatever. The only thing you have to change here would be the way you compute your squares if you're doing Java or C. But other than that, this is how you translate formulas into programs.